Okay, so now that we've named the tool and defined the tool center point, we need to identify the mass and the center of gravity on our tool. Now, mass is the amount of material that's made up of all of this, starting from here back. We're going to count our pin. We're actually not going to count the grippers. We're going to say this whole thing is a tool. Okay, that's different than gravity. Mass is the material, the atoms that make it up. Then we're going to identify the center of gravity. Okay, so if I was to balance a pin, where I put my finger on that pin would be the center of gravity, where it's balanced. So we're also going to identify that. It's going to use some motions, a load identify routine, some feedback from the servos in there, and it's going to do the calculations for us. Plug them in. We start at an absolute joint position of 0, easiest thing to do. You know, there's some things you should make sure you need to do is your speed override is not set. You remove 100% in manual. Make sure your tool is mounted. Okay. So some things we need to talk about on your robot. You have an upper arm load if you had a control box mounted for some welding. We don't have that, so we're not going to worry about that. You've got your tool, your gripper, and then you have your payload. Okay. Now the robot can move at different rates depending on the payload. If we had a large robot, maybe a 100-pound gripper, we'd need to know the inertia of that. Okay, and then say when it picks up a 500-pound motor, we know the payload. It can't move the same with a 500-pound payload on the end of it as it can with a 100-pound tool payload. So we're going to run a little service routine to identify those things. Like I said earlier, that we're going to count our whole gripper and pin as one tool. We're not going to distinguish between that. Now, I entered a mass earlier. Entered a mass of 1. When we set up our tool, I'm not sure this calculation is going to be able to identify this small load. On larger robots it would, so it probably won't change. But what will change is our center of gravity. So, starting at the absolute position of the robot, we're going to come over here and we're going to call a service routine. I'm going to type the debug. We're going to do debug, and we're going to call up a routine. We're going to type call routine, and we're going to call the load identify routine right here. With the dead man grip enabled and in manual, I'm going to hit the play button to run this routine. It's going to warn you that you're going to lose your programming position, and that's okay. So we're going to click OK here, right there. Now it's going to ask, are we going to identify a tool or a payload? Okay, well, we're doing a tool. So we're going to select tool. It's going to warn us a few things. Mounted arm load must be defined if we had a control box mounted on the arm, etc. Or to confirm that everything is okay, we're going to tap the OK button. Now, in the jog window, I selected my active tool as pin, which you need to do before you start this. So in jogging, if you did not do so, you need to make sure your active tool is pin. That's one we defined earlier. We're going to hit OK. We don't know the mass of our tool, so we're going to select 2, which is unknown mass. And then tap OK. We're going to now select our degrees of movement. We're going to go with positive 90. If I was in maybe a large tool, I might set something different, but we're going to let it move up to 90 degrees, how it wants to in automatic. So we're going to go to 90. Here it's going to ask, would you like to do the test in manual first before you go to auto? In slow speed. We don't want to do that, because if we do that, we're going to be here all day. So what we're going to do now is select no. We don't want to run with slow speed. Now it's going to ask us to switch to automatic mode. Okay. Now when I let go of my dead man's grip, we're going to lose the screen. That's okay. You don't mess with anything. Hit the play button. It's going to pick up right where it left off. And now we're going to go to automatic mode. So we're going to come back down to our controller. We're going to turn the key switch into automatic. Our teach pendant is going to warn us that we did that and ask for confirmation. We're going to do OK. We're going to enable the motor on button, not the blue button. Don't do brake release. The motor on button. Now we're in automatic mode. We're ready to go. So we're going to come over here and finish running our load identify routine. I don't need the dead man's grip now because we're in automatic. All I have to do is hit the play button. So hit the play button on your pendant. It's going to come back to our previous screen where we were at, saying, are you ready to move? When you move, you need, this with a large robot, you need to be out of the way because it's going to make some erratic movements in automatic. So we're going to hit the move button and let it run a series of tests. Notice it's very slowly moving. It's going to continue to run these tests for a while in different configurations. So we're going to skip ahead till it's done. Now that we are done with our load identify routine, we're going to go back into manual mode with the key switch. We need to enable the dead man's grip at this point. And we'll hit the play button once again. It comes back where we left off, telling us to go to manual mode, which we have done. We're going to select OK. And here we see that it actually, well, it did find some mass right there. It actually found a mass of 0.9. I entered a default value of 1. Okay, but it found a 0.9 kilograms worth of mass, and it identified the center of gravity. And it wants to know, do we want to update our tool pin data? We are going to select yes. Okay, and then it promptly ends without telling you it did anything. But if I go back over here to my program data, using the nav bar at the bottom, I should still be on my pin data setup. And if I enter the pin data, when I go down through here, I'll see that it did actually enter those values. Hopefully. Yeah, see, mass equals 0.9. Right here, it updated these values for us. Right there, it updated for us. So now we've identified the mass, we're ready to begin using this tool.